It was October 1853 when the Crimean War started. It was a conflict fought between the Russian Empire against an alliance of France, British, Ottoman, and Sardinian troops. Thousands of soldiers died during the war. With her desire to save lives, Florence Nightingale analyzed the complex army data collected during the war. She found out that 16,000 of 18,000 deaths were not due to battle wounds or related injuries, but rather to preventable diseases, poor hygiene and sanitation during the Crimean War. Her discoveries were shocking. Thousands of soldiers experienced senseless deaths. With her analysis, she helps improve soldiers' hospital, hygiene, and well-being. On her watch, the death rate significantly falls. Nightingale is considered a true pioneer in the graphical representation of statistics. She used a polar air diagram to represent her observation on mortality during the Crimean War. In her diagram, the blue shaded represents deaths caused by preventable diseases. The red shaded represents deaths caused from battle-related wounds, while the black shaded represents deaths from other causes. From the graph, it is easily observed that most deaths are indeed preventable. Nightingale's passion to save lives extends to other countries. Although she never visited colonial India, she analyzed the data collected from soldiers that were sent to her. In 1863, she completed a sanitary reform using comprehensive statistical study. She commented that the major cause of death of Indian soldiers are due to environmental factors like poor drainage system and water quality. After 10 years of operation with the new sanitary reform, the reported mortality among soldiers dropped significantly from 69 to 18 per thousand. Unfortunately, Nightingale was sick and became bedridden at the age of just 38. Despite her health condition, she continues her marvelous work. In 1859, she wrote the Notes on Nursing to lift the well-being and fast recovery of patients. She died in 1910 at the age of 90, serving humanity. The life of Florence Nightingale is a testimony of how mathematics can be used to save lives. The heroic life of the lady with the lamp must be treasured and remembered. Fast forward to the modern era, technology is growing exponentially, advanced medical treatments are now accessible, and the standard of living is at its peak. We already know how it feels like to be in a pandemic. We can still feel the aftermath of COVID-19. We are aware of how important vaccines are. It must be the first thing to discover if a pandemic strikes. Vaccines often contain weakened or dead viruses to prepare our bodies for actual encounters with the foreign objects. But how vaccines are developed? For this video, we will focus on the mathematical part. No worries if you have a problem with math, we will not go deeper into numbers. First, scientists use equations or models to understand the pandemic. The SIR model describes the effect of the virus once it is introduced into our environment. In the SIR model, S stands for the number of susceptible, I for the number of infectious individuals, and R for the number of removed individuals. Using this model, scientists can estimate the rate of changes in each category using differential equations. These equations are helpful to tackle the ongoing pandemic. Vaccines like the COVID vaccine that was injected into you a few years back undergo massive evaluation and testing before its release. The developer of the vaccine might even evaluate multiple antigens to determine which one is more effective to fight the deadly virus in our bodies. That means massive data analysis must be carried out. The developers make major decisions based on the data. That is to minimize the risk while maximizing the effectiveness of the possible vaccine. According to the World Health Organization, the screening of the vaccine undergoes 3 major phases before mass distribution. Phase 1. The vaccine is tested on a small group of healthy adult volunteers. In this phase, the correct dosage is determined, and most importantly, to identify if the vaccine indeed generates immune responses. Phase 2. The vaccine is tested on several hundred of volunteers. In this phase, the immune responses due to vaccine are compared with the non-vaccinated volunteers. Thus, the effectiveness of the vaccine is tested in this phase. Phase 3. Now the vaccine is tested on a much larger scale, which might include multiple countries to test the effectiveness of the vaccine. The aim now is to get as many different populations as possible. During these phases, vast data is generated for scientists to study. Again, we need to analyze this data to make any conclusion. We might need the help of our current technology to help us navigate through this immense data. Of course, the risk is unavoidable in vaccine injection. After all, the effectiveness of the vaccine depends on the specific person's health conditions. That means, death due to vaccine is possibility among weaker patients. After all, it's all possibilities. But it does not mean that we stop administering the vaccine. We cannot risk all humanity getting sick and dying because it doesn't work for few people. I know it is hard pill to swallow, but vaccines are not created specifically for a single person. Vaccines are created to preserve our species against deadly viruses. Humanity must continue. In history, polio and measles are common diseases. Here's the graph of how vaccines reduce the number of affected almost down to zero after a few years of vaccination date. On the left, it's the number of patients with polio over time, while on the right, it's the number of patients with measles. From the graph, we can deduce that if the vaccine is never created for these particular diseases, probably millions or even billions of people die because of measles or polio. The development of drugs and medicine follow a similar procedure to the vaccine. For me, I consider statistics as the heart of medical research. The collection of data from the subjects is nothing if we don't know how to analyze them. Math is needed. The data and the equations help us decide. The goal is to save lives with minimal risk. I hope by now you appreciate the application of mathematics even more. See you in the next video.